Now, the last time that we were here, we were talking about factoring binomials. I know, grief, you guys are so critical. When we were factoring binomials, we had talked about the sum and the difference of cubes, but we didn't actually do any examples with those guys. So that's what we're going to do right now. Now, you have to know the formulas. I will never give these guys to you, because I am mean. That's why people sign up to take me. Alright, so these were the formulas we talked about before. We talked about how there's similarity between these two formulas. And the thing that can help you out is knowing SOAP. Same, opposite, and the sign for the b squared term is always positive. This is what I talked about the other day, right? At least when I was here. So let's start with this example. If I want to factor x to the third minus 8. Now, anytime that we're factoring, we always remember the first thing with factoring, and that's to look for your greatest common factor. Is there a common factor here for these two terms? 1. But does that help us out at all? No, not in this case. The second thing you look at is the number of terms. The number of terms tells you what you're supposed to do. A lot of times students get confused and say, oh, there's so many different ways of factoring. Well, no, the number of terms tells you what to do. Like, would you try to factor by grouping with this guy? Why would you not factor by grouping? It only has 2 terms. How many would you need to factor by grouping? 4. If you had 3 terms, you would expect it to factor as those 2 sets of parentheses with the binomial factors. But I don't have 3 terms, I only have 2. So the first thing you look for when you have 2 terms, and you've already done the greatest common factor, you look for the difference of squares. I have a difference, however, these guys are not squares. So I expect, hopefully, I'm hoping that these guys will be 2 cubes, so I can use the formulas that I wrote at the top of the page. Can you write x cubed minus 8 as the difference of 2 cubes? Like, could you write x to the third as something to the third?
Yes. Yes.
Something like x. How about 8? What to the third gives you 8?
2 times 2 times
2. So what I'm looking at here is I'm going to look at this guy as being my A, and I'm going to look at 2 as being my B. And if that's the case, I can easily match it up with the formula that I have written here at the top of the page. Okay? So when I factor this, I expect it to factor as 2 sets of parentheses. And what goes in here, the first will be a minus b, and the other part of the formula is a squared plus ab plus b squared. I'm just kind of putting that underneath as a guide for me so I can plug things in correctly. So if the first part is supposed to be a minus b, and I have a identified as x and b identified as 2, then what would you say for a minus b? You would just say x minus 2. What's a squared? X squared. Plus a times b is x times 2, so you do get 2x. Plus what's b squared?
2 squared.
It's 2 squared, but I don't want to write 2 squared. I'm just going to write what?
4.
Just write 4. Now, if you were to multiply all of this out, you would get x cubed minus 8. You'd have a lot of canceling going on the inside pieces, but you would end up with x cubed minus 8. Are there any questions or concerns about this one?
Yeah, I got one.
Sure.
The way you got that positive 4, then you're multiplying the negative 2.
No. My b is 2. Okay. So the formula says b squared, so when I square 2, I get 4.
There's already 2 in the first factor, and then you're just basically taking the rest of the 2 and multiplying together to get that
Right.
b squared.
Right. If you took this formula right here and you multiplied it out, there's a to the third, there's b to the third, But all the stuff on the inside here, when you work it out, all that stuff's going to cancel. Okay. Now, since I asked you to make a list of your squares and cubes, this next problem will not be difficult at all. So let's try this one. 1,331 x to the third plus 729 y to the third. Is there a common factor for these guys?
No, it's not.
9 cubed equals 729.
9 cubed is 729, so that's useful. So you're saying this guy's a cube.
It's 9 and 11.
This guy's a cube too, right?
11, yeah.
And that guy said, oh, that's 11 cubed. Well, that's nice. So what I want us to be able to do, before I go straight to the formula, because I don't want you to do that, I want you to be able to tell me, what did you cube to get that first term? What did you cube to get the second term? So what did I cube to get 1331 x to the third? 11 x. Okay. What did you cube to get 729 y to the third? 9y. Now, if you can write that step, this is not factored. This is that thought process that we see that I can write each of these guys as a cube. So this is my A, and that's my B.
Which is 11x, not just 11?
Right, it's 11x. So when you use that formula, you're not just using 11, just like here,
X.
I wasn't just using the coefficient, I was using that whole guy of x. Okay? So, when this guy factors, and he's going to be a doozy, that means he's going to be big and difficult. And I think maybe doozy is one of those words that we don't use anymore. The sum of cubes will factor as a plus b, and the other factor will consist of a squared minus ab plus b squared. So what would you say for a plus b?
11x
11x,
Plus
plus 9y.
11x plus 9y. And what about a squared?
Minus 99xy.
Whoa, what?
11x.
A squared is,
Oh, never mind.
11x squared.
you have to square this whole guy. If you just square x or just square 11, you're wrong. You have to square both of them. So it's 121. Because see, a is 11x, right? And if I squared that guy, if I squared that, that would be 121 and x squared. Minus, what's ab? What's the product of your a and your b term?
Negative 99.
So that's 99
xy.
xy plus, what's b squared?
81 x squared.
81y squared,
Y
right?
squared, yeah.
Now, something that you need to know about the sum of the difference of cubes when you're using these formulas. If you look at the last example up here, x squared plus 2x plus 4 looks like something that could be factored further. But when you use the sum of the difference of cubes, you're not going to be able to go any further. When you use it, you're going to be done. Okay?
I'm just trying to figure out which formula to use.
Well, it all depends on it.
I mean, you're starting out, you're factoring with addition.
Well, the sum has a different formula than the difference one does. But notice that these terms, what you see here, these guys are all the same. That's a, that's b, a squared, ab, and b squared. These guys are all the same, right? Those pieces are all the same. What's different will be the signs. So this guy's going to be the same as what you start with, so it's going to be a sum. This is the opposite of the sum, and this guy is always positive. Just like up here. I had a difference, right? So I start off with the same sign, then I have the opposite sign, and the last guy is always positive. That's how I use this. So I get the right signs here.
So even though you can factor farther, you don't.
Well, I can't factor further. This guy does not break down any further. If you think it
do
does,
parentheses, and do x, x, and then 2 minus 2.
no matter what you do, this guy will not factor using real numbers. I could show you what the factorization would be. It would have radicals, it would have square roots, and it would have imaginary numbers. I don't want to go there. We're not ready for that. Now, next semester, we will be ready for it. So this guy, even though it looks like you can factor, you can try all kinds of things, but this guy will not factor using real numbers. Any other questions or comments about these?